for MIT's luck. Yeah. Well, good afternoon, everybody. First, welcome back to our regular audience who are regular viewers for our Visionaries series. This is our first for 2024. Some of you may have tuned in over the 6 or half dozen that we did in 2023. In the spirit of continuous improvement, we're going to try something a little different. Hopefully everybody likes it, which is we are actually live in a different location. We're doing a little field trip. Now, we didn't venture too far. We ventured from one side of Cambridge or just across the city line in Somerville Davis Square to MIT, East Cambridge. Happy to be here. We are, for today, this first session of 2024, we're here with Graham Turk. First, welcome, Graham.
Thanks, Colin, for making the trek.
I packed water bottles, granola bars in my car to make it down to East Cambridge.
Strange building identifiers at MIT here. We don't use names for buildings, only numbers. So you found it, which is the first challenge.
There's a special map too. There's actually an app for the MIT campus, right? That's
been here 2 years and I still use it all the time.
Yeah. Figuring out time and organizing, helping us get out here. So thank you again.
Glad to be here.
Well, first we should introduce you to the audience. You were a Fulbright scholar. You worked at Green Mountain Power, big utility, number one utility in Vermont, and now you're here at the MIT Energy Initiative. So, you, for very impressive background. I'm going to ask. You probably had a lot of choices about what you could have done out of college after your Fulbright scholarship. You chose energy, which may not have been the number one choice for a lot of people. And what made you think about going to work for a utility?
Yeah, when I came back, I was in Stockholm for that year and did research on energy markets and some very interesting ways of integrating renewables. So that was a great experience to see a little bit outside the U.S. how it's done. And when I came back, I asked mentors and people in the energy world, what would be your advice for where to start a career? And the surprising answer I got was that a utility would be ideal. And I think it was surprising because I didn't know anybody near my age who had worked at a utility, but realized that because so much of the decarbonization work has to be through electrification, the idea was that all is going to have to run through utilities, even if utilities might not necessarily be pushing it, that they would be the potential accelerators of that work. And enough to land at Green Mountain Power, which I think was a slightly different type of utility and got a lot of exposure to the exciting work in the clean energy transition that I was able to all place with a really core ethos around doing good by customers and also decarbonizing.
Yeah, well, it's so very visionary, in fact, as a result, because I think probably there's a gentleman, Paul Saffo, the director of he used to be the director of the Institute of the Future. He used to say the future is now just unevenly distributed. So it sounds like when you were in Stockholm, you saw a glimpse of the future, and then you tried where in the place. So Green Mountain Power was that place.
Yeah, I remember I heard an interview with the CEO then, Mary Powell, talking about how they're off the utility talk about, and so was kind of trying to be somewhere that was shaking things up and changing people's ideas about what a utility could or should do. And was very lucky to work with her. She's now at Sunrun, and they're lucky to have her there, and is a very close friend and mentor.
Oh, that's wonderful. A shout out.
Love you, Mary.
You were at Green Mountain Power. You actually had you got to actually do some of the things you talked about that you wanted to. It sounds like you were involved in a lot of different initiatives, from battery storage to electric vehicle demand management. Any specific projects you go, oh man, that was the highlight, or that was
Yeah, my team there, I was on the innovation team, which I think we thought of ourselves as like a little startup within a big company. And our innovative programs to customers, we would partner with third-party technology providers, work internally with our billing team, our engineering team to integrate those technologies. And so had one pilot that became a full tariff program with Tesla, where we were able to have customers lease Powerwalls, residential batteries, when the grid was down, and in exchange, we would dispatch them to help reduce peak demand, which was a big driver of our costs. And so sort of this win-win where customers got this seamless backup power resource, and we got
the United States who would love to have those kind of programs. So amazing to be able to see that.
Yeah, it was fun. A few kind of one-off projects too. We were able to, the State House in Vermont had an old diesel generator in their basement, and instead of replacing it with another diesel generator for backup, they put a battery inside of it that then we were able to use for similar purposes of bringing down costs for all customers. So the Vermont State House at that point was, I think, the first state house in the country to have for all its emergency loads, which was a fun little trivia question if anyone ever asked that at Thursday Trivia.
It's funny. It's a good observation. One is that government buildings actually, they're in some instances can be the first trials for lots of things. I want to say the White House had solar panels put on it in the 70s. Some of the first solar panels, because they could, right? Now, I'm pretty sure they don't operate. I'm pretty sure they were not very efficient. Ridiculous fortune, but somebody had to be first, right?
Yeah, exactly. I think we saw that too. Even within the state, we had a program trying to tap flexibility out of commercial buildings and industrial facilities. The state of Vermont, they have a big campus in Waterbury, using their building basically as big thermal batteries. So we would preheat or pre-cool the building, without making it uncomfortable for behind the scenes. But by doing that, you can kind of take advantage of times when energy is cheap in the middle of the day, the sun is shining, and avoid using energy later in the afternoon as demands start to creep up.
Terrific. And I mean, successful career there. Now you're at MIT. MIT. It's not Princeton, but it's. Thank you, MIT, for giving us this space. I appreciate it. You're at the MIT Energy Initiative. Could you tell us a little bit about the initiative and also your research here?
Yeah, so I'm currently in school for energy policy, and so in a program called the Technology and Policy Program, where every student in it does research with an MIT lab. I do mine in the MIT Energy Initiative, which broadly is looking at whole system energy decarbonization, and a lot of different prongs of that. There's people working on decarbonization processes like cement making, aluminum smelting. There's folks working on how do you solve transmission bottlenecks on the electric grid. My research within that big broad picture of how to is looking at how to decarbonize buildings and electric cars and the impacts that has on the distribution grid. So we run a bunch of models looking at how vehicles charging at home, how buildings installing heat pumps respond to different energy tariffs. So that's the prices we all pay on our monthly electricity bill, and how need for more investment,
it's an avoidance piece, right? So sustainability, but if you have to buy new equipment, that's not terribly sustainable, right? I have to build it, I have to mine something, build it, install it, right? All of those things, right? Take up other space. And so what you're talking about is a different way of thinking about solving that same problem with what the infrastructure we have today.
Exactly. It's a great point. And that's, I think, a little known fact outside of the very niche world of utilities and regulation is that the grid is dimensioned. It's built for the worst case hour of the year. The time you have lots of spare capacity where you're not using the grid up to that maximum. And what that means is if you can help shape loads, if you can push EV charging to overnight hours when everyone's asleep, or you can push heating and cooling loads to the middle of the day when people are at work, that you don't need to build additional infrastructure while adding more electrons that are flowing. Get to that and show how that can be done through rates. Because if the narrative plays out that as people start to electrify, it just means we build a bigger grid.
Right.
That's not going to be cost effective, and it'll put those targets even further out of reach.
Yeah. 2100, right? We'll always say,
Exactly.
wait for those transmission lines and all that.
Exactly.
And so along that around thinking about market pricing, you have a blog.
Mm-hmm. Shameless plug.
Yeah, everybody go read the power. Also, who doesn't love a good pun? Right? It's a great, and there's so many in the energy space. That's probably the best place to be, right? Is the energy space for all the power puns. But tell us about like what made you write about this specific theme and this topic?
Yeah, partly trying to explain what I researched to my parents and realizing they had no clue what I was. And then kind of the disconnect between, every one of us pays an electricity bill.
Yeah.
Very few people actually look at that bill because it is in some cases deliberately, in some cases not, hard to discern.
Right.
And so the idea was, decarbonization is a mandate. We all people pay attention to it. They understand climate policy, but they don't necessarily understand what's. And yet that, to me, holds so many of the secrets of understanding where the bottlenecks, where the barriers exist. And so kind of started out with just looking at my own bill, breaking it down to say, here's what all of these charges mean, and then diving in and explaining how each of those is connected to decisions that utilities make, legislators make, and how through an exploration of those charges and the prices that underlie them, we can help get to a world where decarbonizing is not only good for a climate perspective, but also for people's wallets and helps them save money as they're switching from fossil fuel-based heating and transportation to electric.
You're saying that by helping individuals, consumers understand their bills, then they may take a more active role in how, which then ties back to your earlier point, which is if I can get somebody to charge at midnight versus in the middle of the day, like we don't have to buy all new equipment.
Exactly. Yeah, and some of it is just understanding, what rates could someone sign up for if they have an electric car to help them bring.
Yeah.
Others is more, fundamental changes that you can advocate for at your state public utility commission. Most people don't know what that entity does or what it means.
Right.
So I think a big piece of trying to write about this and make it understandable for a very general audience is to show here's how to engage if these are issues you care about, and how a lot of in Austin, Texas, Sacramento Municipal Utility District, SMUD in Sacramento are kind of always at the leading edge. We also look outside of the U.S. I think a lot of the, as you said, the future, I don't know the exact quote, but it's happening somewhere else.
Right.
And I think in many ways in rate design and electrification, Europe is way ahead of us. Norway has almost 50% of all their cars are EVs.
Right.
And so they've, in a cold weather place where charging is hard. So if they've figured it out, we can too. And I think in the pricing and energy regulation world, a lot of these things that we're proposing now are not crazy out there things that nobody's ever tested. They're sort of tried and true methods that have worked in other places and people are used to as the normal for them.
Yeah. Well, I mean, also you mentioned Norway, which has both extreme. Oftentimes, people look at Scandinavia and as an example for certain things, and it's not always a great example because it's like, but it's a smaller population and it has like more homogeneous and it does it. But in this instance, it actually is an even harder example because of the weather, and because also they huge distance, they're bigger distances, right? That it's not like commuting in a city, right? Or there's there is one, some cities.
I total believer in that, and I think also a lot of in the energy regulation in the rates world, there's a narrative or an assumption that people will just never change their behavior, and that U.S. electricity customers, they're stuck in their ways, and there's no way they're going to be encouraged to change the timing of when they use energy. I personally don't believe that. I think while it might be tough at first, if you send price signals that make sense, that make it easy for people to schedule devices rather than having to go around flipping on lights. They're just pressing a button and their device can respond on their behalf automatically. I think those are the types of innovations that have been tested and work in other places, and we can kind of bring them into the fold in the U.S.
Oh yeah, that's terrific. It's terrific. Well, now you were talking about electricity and power generation, which is one part, right? But then there's another, which is carbon, right?
Mm.
Which is entirely related, but also distinct. And because the energy, if it came from solar, it might be okay to use that. Whereas if somebody's turning on a coal plant, right? Actually, I want to, I might have a different choice. I might make. And how do you think, pricing and economics play into carbon, not just the energy, not just the kilowatt hours?
Yeah, so I think sort of at one level it's baked in a little bit, where it tends to be that the dirtiest generators for generating electricity are the costliest to run, and so there's some existing mechanism where when the grid is constrained, when energy is expensive, it means that the last generator on the stack, the oil-fired power plant, the peaker plant is running. And that's more costly.
Yeah.
People don't necessarily see those prices, and so that's an issue of, if you don't know that that's a highly carbon intensive, highly expensive resource, you can't do anything to change your behavior. You have no incentive to change your behavior.
Right.
I think there's also kind of the next step of that, of moving beyond what we have today, where maybe you're using a carbon signal to encourage devices to turn on or off. Some of the data centers have started to do this. So I know Google has a big initiative to try to run their data centers off total 100% renewable electricity every hour. So that would be looking at the real-time emissions on the grid and deciding which jobs to run and how they can batch different processes to make sure it's aligning well. I also think about it from a heating perspective. If you have a building that has a heat pump and a backup fossil fuel generating system, maybe there's times where when it's really cold and it's going to be difficult for the heat pump to meet the full heating load of the house, it makes sense to cut over to that backup system for a few hours a year. You could use a carbon signal to indicate that. If the grid happens to be dirty at a certain point where, hey, all of a sudden it makes more sense for us to run that backup generator or the backup boiler, that could be a way to help ensure that you're reducing emissions without increasing heating costs for homes that have pretty constrained budgets for how much they're paying each month for energy.
Well, so it's interesting because you're making examples, or you're providing examples that are not just at the, either industrial or retail, but it kind of spans everybody. Literally everybody is impacted by this. And your data center example is a particularly good one. I think when we think about energy consumption, a lot of people think manufacturing, right? But actually, data centers, right? Google and Meta and AWS, all of those, and Microsoft too, right? A lot of compute, a lot of heat, a lot of energy, and maybe bigger than a lot of it.
I was looking at some projections of load growth in the U.S., so electricity demand growth, and I think a full third of projected increases were coming from data centers alone. I don't know a whole lot about AI, which is a bad thing to admit on this campus, but I understand that it is.
Somebody here will, it's all relative. Exactly.
So yes, I understand that the concerns of energy usage for AI algorithms and generative AI is very high, and something that's getting called out a little bit more now. And so there's a huge challenge that a lot of people here are working on, of how to make more energy efficient AI, because the looming risk of data centers just all of a sudden taking up all of global energy demand is not entirely insane at this point.
That is it's funny. I want to say that there's statistics about, the PlayStation 5. So these AI models all use GPUs, these graphic processing units, which are much more energy intensive than CPUs. And, something like a PlayStation 5, uses, has these big GPUs in the Xbox, not Sony or Microsoft, like either equal opportunity, but they both consume, the same amount of power that a supercomputer, consumed in like 2000, not like in the 80s, but not that, they are literally these supercomputers, and the energy is, consumption is high, which people don't realize, when they plug them in at home. Right? They had no idea they were buying a supercomputer. Well, then, we were talking, there's the corporate or institutional part, residential. Now, alongside that, there's this new rule that's was put out a few years ago, but really kind of started to become an impact now. It's by FERC, the Federal Energy Regulatory Commission, FERC 2222, and that has it basically says there's lots of things in it, but one part is a smaller amount, of energy can be pooled
Mm.
and can participate in these markets where you can get compensated, not just actually turn something down and it's good for everybody, but also, or you may reduce your bill, but you might get paid also and compensated. Uh, you know, what do you think about that rule? How much does it
Sure.
impact this area that you're thinking about pricing?
Yeah.
And then I have a follow up.
Yeah, sure. So I guess, yeah, I'll step back just to give a little of the history of capacity planning. So
Yeah.
I think that, historically utilities planned for how do we meet demand at all hours of the year, and
Right.
that was really done exclusively by how many power plants can we build, so that as demand grows, we're making sure that we're providing the additional kilowatt hour without having any reliability issues.
Right.
I think that the changing paradigm that it's just as valuable to generate another kilowatt hour as to reduce one on the demand side.
Yeah.
It was understood, but it took a while to codify that in some of the planning. And I do think FERC 2222 is one big breakthrough there, saying that as grid operators make these plans, they really have to consider the value that small aggregated devices can provide.
Yeah.
And different parts of the country are farther or less far ahead on implementing it and kind of unlocking this value. But it's exciting because it was a FERC ruling, so all of these regional grid operators have to comply with it. And the idea that it's, for a long time, these devices have kind of been locked. Their flexibility has not been fully realized.
Yeah.
And if customers can get paid, and if there's new businesses that can spring up, attracting and recruiting these customers, it means that you can meet that reliability need without building additional generation, and also helping to provide money for these devices, which are often, associated with other clean energy targets.
Right.
It's battery deployment, it's rooftop solar, it's smart thermostats connected to heating systems, electric heating systems, and the more value you can throw into those customer economics, I think the more attractive it's going to be to make those decisions to purchase that, all electric heating system or an electric boiler or a solar battery system, which can only help accelerate adoption.
Yeah, no, that makes a lot of sense. And you have the compounding fact, which is, the devices, or I don't know if you call a car a device, but like the EVs or your PlayStations are consuming some power that is 10x of what it was just a few years ago, and so now you're like it's easier to make an impact, right? My phone charging does not make that much of an impact, but
Exactly.
your EV does, right?
Yeah.
So
I think
everyone now plays a role.
Whenever I look at just like the sheer numbers of an EV compared to a traditional, a typical home's load,
Right.
it could be 60% of a home's electricity load in a year. So EVs especially are just these massive electricity users, which, in some cases that sounds bad. We're using more electricity. That has to be a bad thing. In this case, it means you're not using gasoline.
Right.
And EVs are much more efficient. And obviously, even on a grid that has mostly fossil fuel generation, it's a huge carbon saver.
Yeah.
And I think that when you consider the flexibility that's inherent in charging, most people are leaving their cars plugged in for 12 hours overnight.
Right.
They might only need to charge for an hour in that span.
Right.
That's a lot of flexibility to shift and move those kilowatt hours in a way that helps make really efficient use of the grid that's already there.
Yeah. Well, and so in that, so smart charging, right? So I'm able to move my time, and then with rules like FERC 2222, I'm able to get compensated for it. This may be a little wonky, but settlement times, right? Real time, so how fast is there one part is how much I get paid. It's a different part of human behavior, which is how quickly if I see something on my bill 90 days from now, that incentive may be different than, it hit my phone, they Venmo'd me or whatever, right away. I see that. Do you see settlement times coming down? Do you see that as an impact in this area? Or?
I think for sure. In terms of motivating some of these actions, if you get an alert that says, "Hey, for $10 today, you can reduce your thermostat by a few degrees," I think that immediate feedback is very helpful. I think the other thing is, the grid is operated on a millisecond to millisecond basis. So if there's the ability for grid operators to get that data and know, we asked this device to turn down, it actually did. It gives them more certainty that these are devices that can be relied on. I think that a lot of the perception for years was that customer cited devices are great, batteries, but when it really comes down to it, we can't bank on them to show up when we need.
Yeah.
And having that real-time verification totally debunks that myth that you can't rely on an aggregated fleet of batteries or on lots of EVs instantaneously dropping or increasing their consumption to balance the grid. So I'm excited that technology is now there, and that it's at least the grid operators have to consider it when making these plans, because they've been there for a long time and they've just been overlooked in being a really valuable resource.
It's funny when you I think it's a great point, and I think when you're talking about sort of pooling these assets, can you rely on it? And many people, well, not many people may be old enough to remember in the 90s when today home mortgages are all traded, right? There's a whole pool of secondary market that, this multi-billion dollars and all kinds of things. That market didn't exist initially because no one, in the United States, there's a rule which is you get to pay back your mortgage when you want. So I can't securitize an asset because I don't know when they might call it. But they put them together and pooled it, and then all of a sudden I can trade mortgages, right? And 30 or 50. And it sounds like there's sort of a similar. It's like, oh well, if mathematically I can pull these things together, right? Then I can have more active. I can rely on it for.
Yeah. Exactly. I think that it's exactly flipped, like you just said, where if you care about having a very reliable asset to help meet demand at the moment you really need it, would you rather have a gas plant where if anything goes wrong, you lose potentially a gigawatt of generation in an instant, versus thousands of batteries where you might lose 10%, but that doesn't mean that the whole resource is down. So you're kind of, like you said, pooling the risk, the probability that every one of those fails compared to a single point of failure with some of these large generation plants. It's just so much lower. And I think that you're starting to see regulatory commissions acknowledge that and saying, hey, it looks like you're making these plans to build lots of new generation. You're not considering the value in distributed batteries and demand response, in rate design. And I think it's been hopeful to see more and more regulatory commissions considering those and enforcing that utilities think about it in their plans.
It's funny you say that because of course that's impacted, we often think, oh, well, what are the odds, right? That, but your distributed assets are clearly lower risk than a single point of failure, as you say. And the only, one of the big places not regulated by FERC is Texas, which has seen, extreme weather. And when you get, snow and ice, and now you do have that single point of failure, right? And as we, see more frequent extreme weather, we're going to see, hey, we can't rely on that one source because it's too cold for it to run, or it didn't start when it was supposed to. It wasn't designed for that.
Yeah, exactly. I think the report came out, I don't want to cite the exact figure, but a very high percentage of gas generation was offline during Winter Storm Uri. To your point, that I think gas has for a while been considered this gold standards of reliable generation. And it turns out that when there's extreme weather and power plants are poorly weatherized, it can't be relied on. So I don't think that means you put all your eggs in a different basket, but you have to have a diverse portfolio so that if something does happen and all of a sudden you have way over invested in one resource, that it doesn't mean that the grid goes down and there's rolling blackouts for millions of people.
Oh, true. Well, this has been excellent, right? As a conversation, I think we love deep topics. I actually have one final question for you, which is, I know it's February, but hopefully not too late in the year to ask you for like some predictions around 2024. How are you, anything? I mean, see, energy versus sports. Nothing easy. It is Super Bowl next weekend, but but if you have any thoughts about like big things that you think or you're looking forward to or have to see this year.
Yeah, I think and I'm in the policy and regulatory world, so what a breakthrough prediction might sound like for me might not be super exciting.
It's an election year though, so who knows? Anything's possible.
I go to I think a lot of the regulatory developments that are happening where commissions in many states are going to utilities and saying, we're going to require that you incorporate demand flexibility into your planning. I saw that Colorado just made a proposal for Xcel Energy to build a virtual power plant. I saw there was a virtual power plant stood up in 6 months in Ontario with 100,000 homes. So I think just the speed of deploying these resources and regulators' willingness to go to utilities and say, you have to consider this in your planning. That's really exciting to me. There was also an order recently in Massachusetts where the regulator essentially told natural gas distribution utilities that in order to meet demand, before you're able to build any additional gas pipeline infrastructure in accordance with the state's climate law, you have to consider alternatives. And that could be a combination of district heating, of geothermal, of heat pumps with backup storage. And so I think that there's a slow but very exciting shift in some of these state regulators and looking at utilities and saying, you are required to meet reliable service at least cost, and we're going to interpret that in a different way than we have historically, because now all of these new devices are available for you to dispatch that you hadn't had access to before the advent of more connected devices.
Oh, it's terrific. There's a whole other conversation we didn't have about, but utilities are incentivized by return on assets. Now they don't get to buy those we'll save that for a different session. For today, just thank you, Graham, for the wonderful conversation and for taking the time to speak with us today.
Yeah, it was a pleasure, and thanks again for making the trek out to campus and braving our very difficult buildings.
I got through. They gave me a badge. I got through. I passed security test. So. It's not quite the Pentagon, but close. Terrific. Thank you very much. And we're out.